Have you ever wondered why things fall down and not up? Or how we discovered that the Earth orbits the Sun? Now, what if I told you there was a man who pondered these questions long before we did? A man who forever altered our perspective on the universe, whose name is so revered it's inscribed on currency. A man whose hidden passion for music was as fervent as his pioneering theories. And yes, he had a transformative encounter with an apple, not the iPhone, but a real fruit. What was so remarkable about this individual that he was bestowed the title Sir? Welcome to Rapid Rewinds, where today we delve into the legacy of one of history's most brilliant minds, Sir Isaac Newton. The Christmas of 1642 gifted the world with the birth of Isaac Newton, who was born in Woolsthorpe, Lincolnshire, England. According to his mother, Hannah, he was so tiny that he could fit into a quart mug. He was the only son of a farmer, also named Isaac Newton, who had died 3 months before his birth. A few years later, his mother, Hannah, remarried. His wealthy stepfather, Minister Barnabas Smith, then sent him to live with his grandmother. After Smith's death, Newton reunited with his mother. She wanted him to become a farmer, but he wasn't fit for it. So, he went to a grammar school in Grantham, England, preparing for university. Initially, he wasn't a strong student. However, after clashing with a school bully, Newton became determined and evolved from a mediocre student to a top performer. There, he began showing skills in mechanics, building models like clocks and windmills. After finishing his coursework there, Newton left for Trinity College, University of Cambridge in 1661. During his undergraduate studies at Trinity, Newton's mother couldn't fully support him financially. So, Isaac took up odd jobs to fund his education. He waited on tables, cleaned shoes, and, being a responsible student, he kept a record of his daily expenses in his notebook. During this period, the scientific revolution was in full swing, and while old theories like Aristotle's Earth-centered universe were still taught, Newton was exposed to newer ideas. Notably the sun-centered model from scientists like Copernicus and Kepler. Newton wrote notes titled Questions Quidem Philosophicae, certain philosophical questions, where he said, Plato is my friend, Aristotle is my friend, but my best friend is truth. This reflects how the scientific revolution profoundly influenced him. In 1665, Newton earned his bachelor's degree. Later that year, as the Great Plague struck London, 23-year-old Newton left Trinity College, Cambridge, and took refuge in his family's Woolsthorpe manor. Away from the epidemic and in a peaceful setting, Newton's creativity flourished, leading to what's termed as the Year of Wonders or Annus Mirabilis. First, Newton continued working on math problems he had begun at Trinity. He sought solutions for specific equations that French mathematicians Descartes and Fermat had previously explored. By the end of 1666, Newton had effectively found the solution and wrote about flux science, which we now refer to as calculus. Newton studied optics, challenging the idea that colors were a blend of dark and white light. Through an experiment with prisms in his room and a light beam coming from a hole he drilled in the shutter of his window, he discovered that white light contains all the colors of the spectrum, and each color remains unchanged when refracted. During this time, the famous story of Newton and the falling apple leading to his insights on gravity emerged. While the exact events might be different, Newton did ponder why objects, like an apple, don't just fly off the earth. He believed the same force pulling the apple down also attracts the moon to the earth. This thought led him to the law of universal gravitation, which says these forces relate to the object's masses and the distance between them. Though his early calculations weren't perfect, he refined them by 1687 for his renowned work, the Principia. By the spring of 1667, as the plague subsided, Newton returned to Cambridge and was elected to a fellowship. His experiences during the plague set the stage for his revolutionary contributions to science. In the quest to magnify the cosmos, Sir Isaac Newton introduced a groundbreaking invention in 1668, the reflecting telescope. Differing from traditional lenses, this telescope utilized a curved mirror to gather and focus light. This pivotal innovation not only minimized color distortions but also heralded a new era in astronomical observation. In 1669, Newton was appointed as a professor of mathematics at Trinity College. In that same year, he penned the tract titled De Analysi per Equations Numero Terminorum Infinitas, translated as On Analysis by Equations with an Infinite Number of Terms. Over the subsequent 2 years, he undertook revisions of this work, eventually presenting it as Tractatus de Methodus Serierum et Fluxionum, meaning on the methods of series and flux science. Concurrently, during these transformative years, Newton initiated lectures at the college, elaborating on the extensive research he had conducted in the field of optics. Newton also had a keen interest in music, showcasing his talent through the violin and even designing his own harpsichord. As the rich melodies of the Baroque era emerged in his time, some think its musical innovations echoed with Newton's scientific views. Many theorize that his love for musical harmonies shaped his understanding of the universe's order. Newton presented a paper to the Royal Society discussing light and colors. While it garnered mostly positive feedback, it faced some opposition, notably from a prominent society member, Robert Hooke. Distressed by the criticism, especially from Hooke, Newton chose to distance himself and retreated into near solitude. Back in 1684, Newton sent a short paper called De Motu, which means on motion, to a British astronomer named Edmund Halley. After refining his work, Newton released a game-changing book, Principia. It's where he unveiled the 3 golden rules of motion and introduced us to the pull of gravity. Newton proposed these laws to explain how objects move and why they change their motion, laying down the foundations of Newtonian mechanics. According to the first law, also known as law of inertia, an object will remain at rest or in uniform motion in a straight line unless acted upon by an external force. According to the second law, also termed as the law of acceleration, the force acting on an object is equal to the mass of that object times its acceleration, F equals ma. Whereas the third law states that for every action, there's an equal and opposite reaction. Newton's final years. Newton got the job as the warden of the Mint and shifted to London. He stayed connected to Cambridge till 1701. After becoming the warden, he soon leveled up to the master of the Mint, handling the money-making business. Newton took charge of introducing new coins and really enjoyed using his power to nab those making fake money. In 1703, Newton was elected president of the Royal Society, a position he held for 24 years until his death. In 1704, a rivalry emerged between him and Leibniz, with both asserting they were the true pioneers of calculus. Their conflict over its inception stands as a landmark disagreement in scientific discourse. In 1705, acknowledging Isaac Newton's groundbreaking scientific achievements and his work at the Royal Mint, Queen knighted him. From then on, he was known as Sir Isaac Newton, a title honoring his invaluable service to England, even though it wasn't hereditary and he had no heirs. This occasion marked the first time a scientist was granted such an honor. Under the guidance of Newton, the Royal Society formed a commission to examine the rival claims between Leibniz and Newton regarding the development of calculus. After an extensive review of both mathematicians' work, the commission concluded in favor of Newton. However, many believe the decision was swayed by Newton's prominence in the society. Today, the academic world recognizes the independent contributions of both Newton and Leibniz to calculus. In the twilight years of his life, Sir Isaac Newton, already well established as one of history's greatest scientists, continued to contribute to various academic disciplines. He served as the president of the Royal Society, solidifying its place as a bastion of scientific inquiry. Newton also delved deeper into religious studies and alchemical experiments. His health, however, began to wane in his 80s. It's speculated that his alchemical pursuits, particularly his exposure to mercury, might have affected his health adversely. On March 20, 1727, at the age of 84, this luminary figure bid adieu to the world in London. His burial in Westminster Abbey stands as a testament to his unparalleled contributions to science and his lasting impact on the world of knowledge. Sir Isaac Newton, one of history's most luminous minds, not only revolutionized our understanding of the universe, but also left a legacy that continues to inspire scientists, thinkers, and curious minds around the globe. As he so eloquently put it, we build too many walls and not enough bridges. May we all strive to build bridges of understanding, just as Newton did between science and the mysteries of the universe. This is Rapid Rewind signing off. Remember, legends never fade, they just get retold. Stay tuned for the next one.